So to with the chain rule, but basically let us first introduce ourselves to we remind ourselves of what integration is. So how do we differentiate 2 over x to power 3? Yes. Yes. But this one here would be simpler if we took the 3 upwards, the x to power 3, okay? If this one went up, so that would give us x 2x to power negative 3, isn't it so? So if it gives us 2x to power 3 to power negative 3, then here we do the usual differentiation, yes, where we pre-multiply by the power and then add the power and subtract the power by 1. So when we do the pre-multiplying, we shall have a 3 being multiplied with a 2, so we shall have 2 times negative 3. Then we have x negative 3 minus 1. So 2 times negative 3 would give us negative 6, then x to power negative 4. But since at first it was given in a form which is 2 over x to power 3, so likewise this x to power negative 4, we look for ways to make it what? A positive. So how shall it be if it is taken as, if we want to have it back as a fraction? Okay, negative 6 out of x to power 4. Yes, then we have another one there. We'll differentiate 2 divided by root of x. Yes. 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 Okay. Yes. Yes. Okay. So then we shall have 2 times negative a half, then x negative a half minus 1. So which will give us, so 2 times 2 will cancel out with the 2, so meaning we shall remain with the negative 1 times x. Then, so that was the introduction part. So we can now continue with the chain rule. So this chain rule is majorly used when we are doing like function which has powers, so they are like 2 functions in one. So we are saying, so you can read that. So this one we can easily expand. Okay, so the one on the right hand is the expansion of x to power x plus 4 squared, which gives us x to power 2 plus 8x plus 16. So because we can easily expand this, we can as well use the previous knowledge to get the derivative of that function. So here we are saying if we differentiate that, the x squared is going to be 2x, then the 8x is going to remain as 8. So here it would be quite simple to do the differentiation. You can read the next statement there. Yes. So because here we cannot expand, okay, so this would be okay. It is possible to expand it, but it would take time, and you always know we are always chasing time. So here that is where the chain rule comes in. Okay, so here what we do, we let this function here to be we let this function to be like y, okay, the whole of it, and then we suppose y is a function of u, and then the one inside the brackets we let it to be what? To be u. So with the chain rule we say dy dx, okay, this is a partial derivative, smaller change in y over smaller change in x is equal to smaller change in y over smaller change in u times the change in u of a change in x. So when these smaller changes are very small, so this change in y over change in x tends to dy dx, change in u over change in y over change in u tends to dy du, and likewise change in u change in x tends to dy du. So then we come up with this formula that dy dx is equal to dy du times du dx. So you can see that if we tried to cancel this one, we remain still with the dy dx. So this formula does not change the meaning, only that after introducing the another function u, then we also need to cater for it here. So we are saying this result is known as the chain rule. So now get some examples here. So our first one, we are going to differentiate 3x plus 2 to power 4. So what will be our first step? Yes. Okay, so it means for you had already done this. Yes. Okay, when we are still in the beginning processes, we are going to just do this for those who haven't attended. We let the whole of this function here to be u, to be y. So y is going to be equal to 3x plus 2 to power 4, and then the one inside brackets we let it to be a u. So u is equal to 3x plus 2. So we are going to begin by considering the u. So u is that, and then thereafter that we find the du dx. So on finding du dx, we are going to have this becoming a 3 because it has a power 1 here. So when we pre-multiply and subtract, we shall remain with only 3. And then now our y, which is 3x plus 2 to power 4, is going to now change, since this inside part is now u. So our y is going to be u to power 4. So we also differentiate it, so dy du is going to be 4u to power 3. Then after that we apply the chain rule, which says dy dx is equal to dy du times du dx. So dy du is 4u to power 3, and then du dx is 3. So when we multiply, that will give us 12u to power 3. Then we just substitute back the value of u, so which would be the same as saying that this is going to be equal to 4 times the derivative of the inside one, so which would be 3. Then we reduce the power by 1, which would be 3. So still this would give us 12 into 3x plus 2 to power 3. So they would give us the same what? The same answer. So we are going to still differentiate this. So we begin by letting the y to be equal to x squared plus 3x to power 7, and then u is equal to the one inside the brackets, which is x squared plus 3x. So we can begin by differentiating this. So we shall find the du dx. So the du dx, so this 2 will come here, so that will become 2x, and then this reduces to 1, so du dx will be 2x plus 3. Then now our y is equal to u to power 7. So what is dy du? u to power 6, and still we apply our chain rule, so we shall have 7u to power 6 times 2x plus 3, which was du dx. So we shall have an answer here. So when we multiply, when we substitute for the u, we shall have 7 into x squared plus 3x bracket to power 6, then multiply it by 2x plus 3. So that would be the derivative. Then how would we go about that? Yes. 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 Okay. Yes. Okay. So we are saying that would be that. So we get 1 times the inside one, so we reduce the power by 1, and then multiply by the derivative of the inside. So we should be negative 1 times 1 plus x to power half to power negative 1 minus 1, and the derivative of the inside would be a half x to power half minus 1. So that would give us here power negative 2, and these other ones would remain the same. So which means since these ones are to power, they are going to go down to the denominator, even this one. So that is why here we have negative 1 divided by 2, x to power half, then bracket 1 plus x to power a half, then everything squared. So this would be the derivative of 1 divided by 1 plus root of x. So which we can further simplify into 2 root of x, then 1 plus root of x to power 2. So this is in a more simplified form sign. Okay. So that is the chain rule. So the chain rule as well enables us to investigate related rates of change. So had you done some rates of change? Okay. So you can read that statement. So how would we approach that? Yes. 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 So this is 4 over 3 pi. Okay. This one here. So this one here, we are majorly getting it from here, that here we are going to divide by 4 pi r squared. Then still here by 4 pi r squared. So that this one cancels out. Then we remain with the r dt equaling to 2 over 4 pi r squared. So this one as well cancels out. So by 2 is 1, by 2 is 2. So we remain with 1 over 2 pi r squared. So here our dr dt would be 1 over 2 pi r squared. Okay. So we have this. At a container in the shape of a right circular cone of height 10 centimeters and base radius 1 centimeter is catching drips from a tap leaking at a rate of 0.1 centimeters cube 0.1 cubic centimeters per second. Find the rate at which the surface area of the water is increasing when the water is halfway up the cone. Jerusha, first give us some approach there. Yeah, it is okay. Yes. Which is here. The water is here, no problem. Yes. 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 The height. So for you are going with height. Okay. Let us first do it your way. So height is equal to 10r. Yes. Divide. So here we divide is equal to yes. Okay. 5 centimeters. Here. let me first rub off some few parts here. No, these ones I think. Okay, continue. Zero 0.5. I thought this was 1/25 pi. Yes. One out of 25. Okay, let us cross-check this with what I had. Joel, is everything okay? Hey, that is pure math. Yeah, you need to do a lot of practice, because you see Jerusha has been able to assist us here. So let's just go through this. So I began. So there I found the ADH, which gave me pi over 50. No, pi h over 50. Then I used the ADT there, so which was the ADH times the HDT. So I substituted for that. Then I also got the formula for volume, still substituted for h where there is r, and that gives me pi h to power 3 over 300. Then here I had to find dh, dvdh, which gives me this. So after getting this, then I come back and place it here where there is dh. So dvdt is equal to that. So dvdt was given as 0.1. So we substitute there. Then dHdt was able to give us that. So we substitute in the other formula for the ADT. Then we are able to get 1 over 5. So when h is 5, the height, so we are able to get that. So I think Jerusha, we have the same answer. Yeah, so it is the same answer. So we are saying therefore when the water is halfway up, the rate of change of surface area is equal to 0.04. I think it shouldn't it be centimeters squared per second, since it is So that was that. So I think this was some assignment. So that was to do with the chain rule. So we can briefly look at one of product and quotient. So the product rule is when we are multiplying two functions, u and v. So we begin by letting y to be a product of two functions u and v of a variable x, such that here our y is equal to uv. But remember, these ones have small changes in them, the increments. So majorly here our aim would be to find the formula. So we say y plus change in y is equal to u plus small change in u plus that. So when we open brackets, this would be uv, u change in v, then v change in u, then change in u change in v. But remember, this is equal to y, so these two would cancel out. Then we remain with change in u, which is u dv plus v du, then plus du, change in u. So we divide through by change in x, since our aim is to create a change in y over change in x, which will finally give us a du, a dy dx. So here, after getting this, after doing the division, we are going to say as delta x tends to 0, or since those small changes, since the changes are very small, as the delta x tends to 0, change in u, change in that, those ones tend to what? So these ones here would tend to 0. However, here a dy, a change in that over this, will tend to du dx. Then change in v over change in x, this will tend to dv dx. And then we come and substitute. So that one is also there. So we shall finally end up with the formula change dy dx is equal to u dv dx plus v du dx. Are we okay up to that point?
Yes.
5 minutes.
Sorry.
So we got one example because of time. So we differentiate the expression y is equal to x to power 2 minus 3 into bracket x plus 1 to power 2. So we need to begin by letting one of those functions to be y and another one to, one to be u and another one to be a v. So who can explain how we shall go about that? Yes. Yes. No, v because the x is already there. Okay. Okay. Yes. Okay. Okay, so here when we differentiate this, it will give us 2x here when we differentiate x plus 1 to power 2, it will give us 2 into x plus 1. Now then we substitute in this formula, dy dx is equal to u dv dx plus v du dx. So when we substitute, our u is x squared minus 3, then dv dx is 2 into x. So we are going, so we factor out that, and then, okay, I think here 2 into x plus 1 into x squared minus 3 plus that. Okay, then here we factor out 2 into x plus 1, so we remain with x squared minus 3 plus x into this. I think we can as well open brackets here, such that we shall have x squared minus 3, then this times this would give us x squared, then this times that would also give us x, such that we now have 2 into x plus 1 bracket, then 2x squared plus x minus 3. So when we try to factorize out this, it will give us 2x plus 3 into x minus 1, and that would be the derivative of our function. Any questions?